Hello, my name is Askar, and it is a first demonstration of the TAMARA. TAMARA it is acronym of Threat Hunting with AMSI and YARA. This it is an open source project. It's my pet project, and it published on my GitHub. Here is the link. Here, the first page, you may see the brief documentation for this project. It is description where I provided the motivation and some technical details about this project. Also, it contains installation guide. It is very short, but for experienced developer, it should be understandable. Also, there is a special uh, notice or like a ask to contribute to this project. The best way to contribute is test this software, look at its code, and maybe you have some feature requests. And for me, it would be helpful to uh, add some new functions related to this project. So let's describe briefly what for it is. I realized that it is difficult to find a tool that will help threat hunting team, SOC team, to conduct threat hunting. So I thought why we can't use YARA rule to scan processes inside of the system, and that's why to detect some malware. And you may think that why it is needed because we already have antiviruses and EDRs. But what if you have a malware that you cannot send and share to uh, antivirus companies, or maybe you don't want to send it? Uh, another another case is when um, the addition of the malware into the signature by database, it is maybe time-consuming process. And what if you need to do threat hunting now and to detect malware at this moment? So that's why I uh, thought that we need some tool or set of tools that will help to do this work. Um, so Tamara, it is not uh, not one tool. In fact, it is set of tools. Currently, it consists of 4 tools, and AMSI injector is in progress, but others exist. So most important tool, it is AMSI scanner. It is a DLL that provides a scanning feature. It uses YARA uh, as a signature engine, and also it uh, call it is called as a AMSI interface. So you know AMSI, it is a anti-malware scan interface. It was first introduced in uh, Windows 10. So it uses this feature. This feature is embedded into Windows 10 and Windows 11, of course, and we can use this to scan uh, some data. One more problem with this AMSI interface is that to scan some data you need to send this data into this interface. So if some program, some software does not integrate AMSI features, of course, data there would not be scanned. That's why there's another DLL is created. It is AMSI forced scanner. In fact, it is a DLL that would be injected into a monitored process, and it works like a uh, mm, so it would be injected into the executable, and it will change the path of the some binapi functions, and we will use it to send data to our first library, this AMSI scanner. Next, AMSI injector, it is just an executable that receives some uh, uh, some privileges. I think I see the bug privileges, and tries to inject AMSI forced scanner into each of the executables. And last one, AMSI test. It is, of course, testing executable that we will use to check that everything works correctly. So here are some instructions for installation and starting. Of course, I already installed it. Here is we have a folder inside the C program data THAMARA. We have a AMSI forced scanner, AMSI provider, and AMSI test. So we already done first, second, third. Step number 4, it is checking the rules. Here we have a rule. It is AMSI test rule. It just contains 3 strings. And here is a sample bin. Sample bin, it is just a binary file that contains all of these strings. And it is, of course, used for testing purposes. Also, we have the YARA executable. It is a standard YARA binary that download from official YARA repository from GitHub. Okay, so what next we need to do? When we install this, we need to start it using this command. Here I have a command line with administrator privileges. Okay, so we entered this command, and here this command it calls a DLL register server. Let's see at the code what happened. So it is a project inside the Visual Studio, and the small library it contains a few functions, and this this DLL exports two functions. First, it is a DLL register server, and second, DLL unregistered server. Both of them works with process or program named as a regsvr 32. So when we call in this way, without any parameters, the DLL register server starts, and what it do, it writes, it registers our AMSI provider in the system registry. So here is a some registry case. Software classes. It is a class of the of this AMSI provider. Then we can see here at the software Microsoft AMSI provider this this provider, THAMARA provider, is also registered. What next is important? Yes, here we have a class and its function scan. When it called, it just opens this file with rules. We already seen it before. And then it initializes standard YARA scanners. It is a here initialize, create compiler, added the rules and other features that are standard for YARA lib. So here is the most important function. We send address and size, address of the buffer and size of this buffer into this function, and we receive some result when this it's like a global flag. If we found some signatures, some matching, here is another code. We just form a string that would be written into the AMSI log. That's all for this DLL. You may see that it's quite simple. It is just a regular code that's standard for each DLL that use YARA lib. Also, it of course calculates a SHA-1 hash, which will be also included into AMSI.log. So here we registered this DLL as a AMSI provider. So next important DLL, it is AMSI forced scanner. It is also simple DLL. The most important thing is here we create a prototype for four functions that exported by NTDLL library. They are write virtual memory, read virtual memory, decompress buffer, and compress buffer. Why this? Because I'm as a malware analyst, I saw that these functions are often used in malware, and we can detect this some malicious data from these functions. So it define these prototypes of these functions, and then it using a Microsoft Detour library that is statically linked to this DLL, and it uses internal functions of Detour to hook these four functions. So here we can see at the DLL main when the DLL attached to the process, it attach also creates hooks, and when a DLL detached from the executable from the process, it detach the hooks these functions. So what happened inside these functions? Let's see. For example, this function, it is nt write virtual memory. So first thing, what it do, it just calls true true address of the original function. And then after this, we check is buffer is have a read privilege. Here we can see we have a special function for this check read, and it checks using virtual query function. And then it just creates a debug string and call a scan buffer function where the where it sends address of the data and size of the data. Let's see what happened here. So here we have a function scan buffer. It receives a buffer length and content name. What it do? It just do a standard AMSI. It just calls a AMSI interface to scan this buffer. So here you can see that there is a AMSI initialize, AMSI open session, and so on, etc., etc. And main function here is a AMSI scan buffer. So we send this buffer to AMSI provider. So since we already started our previous project as an AMSI provider, it's obvious that this data will be transferred to this AMSI provider also. So that's all for this second project. And let's consider just an AMSI test. Here we have it is an executable, small executable. It just conducts, it just calls set of functions that typical for working with memory. It is virtual alloc, also virtual alloc and virtual alloc X. We copy memory, we change in protection rights to the segments and etc. etc. And also we here have a read process of memory, write process memory functions. It is a native AMSI checking. Also, we have RTL compressed and decompressed functions. So, and it ends with virtual memory. So, also before starting of these functions, we have a most important function. It is a load library. So here we loading AMSI Force Scanner. It is this second project. We loading is we are loading it using this function load library because our injector I mentioned it before. AMSI injector it is not ready now, and that's why for testing purpose we use this way to call AMSI Force Scanner library. So let's go to the demonstration. We already called req and registered our provider as a AMSI provider. And here we just need to call a AMSI test. So let's enter. Okay, so here we have some log from some output as a log from the AMSI test program. So virtual alloc OK, it is here, and size and pointer. Virtual protect read process memory. OK, we call the read process memory. It is kernel 32 function, which internally calls a function NT read virtual memory. So when we call this function, inside it, inside WinAPI, the NT read virtual memory is also called. Okay. So let's check log. Let's check AMSI log. We see that it created. So here we have a AMSI log, and from here we might see that firstly the NT read virtual memory is called. Yes, it's okay. Then NT write virtual memory. Then a native AMSI checking was called. We using oh no, it's not here. Yes, here is a function that in a direct way calls AMSI interface. Yes, native AMSI test. Yes, native AMSI test. And also we have a RTL compress buffer and the compress buffer. These strings shows that we have a matching this AMSI test rule. And here in AMSI test, we have a binary array that obviously matches with our rule. So feed babe, that code, Facebook. Yes. So here also it matches the rules, feed babe, that code, and Facebook. Uh, that's all. If you have any questions, feel free to uh, create a, request to create an issue here, and maybe we can discuss some new features to this project. In future, I will implement, of course, a AMSI injector. Since it is a POC or pet project, first as a first stage, I will implement it as executable. But in future, I will try to implement this injector as a Windows driver. So in using driver, it would be more effective because we can inject it in much more amount of processes. Okay, that's all for today.